going on, we will be recording it, so we can house it out there on the YouTube channel. Okay, guys, I'm going to go ahead and share my screen. And Andy, we'll let you kind of be the scribe a little bit as usual, and you can tell me how everything looks and stuff like that once I pull up the PowerPoint.
Sure will.
Yeah, we can see her. We're good there.
Okay. And so we should be just on that front screen showing two pieces of equipment. Is that correct?
Yep.
Yes, sir.
Well, fellas, good evening. Again, appreciate you giving us the opportunity to train with you tonight. We're going to be, first and foremost, there's a little bit of an echo that you can kind of hear because I'm in my new office in my new home, and I don't have any furniture in here yet. So hopefully this echo won't bother anybody too bad, behind me, so to speak. Okay, so tonight we're going to be looking at the HMH7 SEER heat pump, and specifically, we're gonna touch on some key points today. So the first thing we'd like to talk about is please remember, and we're getting a little bit of feedback. So how about everybody shut their speakers off or shut their microphone?
I'll mute the mic here.
There we go. I think that helped. Good. All right. So please remember the unit service fittings are 5/16 on the units, and you're going to need an adapter to go between that 5/16 flare fitting down to a 1/4-inch flare fitting, so you can get your service hoses on there so you can service the equipment. And these little adapters, they're very, very common. Robinair makes them, JB makes them, several companies make them. But just remember and remind the service technicians they need a 5/16 by 1/4-inch flare adapter so they can hook their hoses up for servicing these units. In addition, you're going to also notice that there's two platforms. You've got a 2-fan model and a single fan model. Well, the 2-fan model will be the 4 and 5 ton units, and the single fan models will be the 2 and 3 ton units. So you can look at them at a glance and say, oh, gee whiz, that single fan is either a 2 or 3 ton, or the 2 ton or the 2-fan model will be either a 4 or 5 ton unit. Another question we get asked quite a bit, on the new HMH7 SEER heat pump is the fact, well, how low will it cool to and what's the maximum it'll cool to? Well, this little chart right here is right out of the install information. So it'll go down to 35 degrees for cooling and up to 122 for cooling. And then in the heating mode of operation on the outdoor coil, it'll actually heat all the way down to -5 is where it starts to actually lock out. It'll lock out at -5 or -6. So that's a pretty good range if you think about it in the heating and cooling mode both for the outdoor unit. The other thing we always like to point out right away as well is the unit, even though it kind of looks like a mini split, it is not a mini split product. Let me say that one more time. This is not a mini split. It kind of looks like it. It's got some similar compressor technology as far as inverter drive. It'll actually modulate from 35 to 100% capacity. But I want you guys to think about it it's just a heat pump. It's just another heat pump. You're going to run a suction line that you're going to insulate like you normally would. You're going to run a liquid line, no big deal. You're going to have a conventional thermostat inside. This is a non-communicating, extremely simple 24-volt hookup. Just use your favorite heat pump thermostat on the wall. So even though it kind of looks like a mini split, it is not a mini split. I want to stress that one more time. It's just a heat pump, and treat it just like any other heat pump, except it just looks good and it's a horizontal discharge. So at this time, fellas, we're going to go ahead and talk about hooking this thing up. And we're going to be looking at some low voltage wiring and setup of the HMH7 SEER heat pump with an AE air handler, which is going to feature a standard, just a plain high efficiency ECM motor. Now, at this time, we're also going to be looking at a low voltage block wiring diagram, and we're going to literally go from wire for wire from the thermostat to the indoor unit to the outdoor unit. Please note the AE air handler has no terminals, but is equipped with pigtail connections. So even though we kind of show a terminal spot on the PowerPoint slides, it's a lot easier just to show where you're landing on a terminal than it is in a PowerPoint than to try to draw some pigtails or wires. So even though it looks like we're landing on a terminal, we really have pigtail connections on the air handler product. In addition, we're going to talk about wiring of the accessory single pole double throw relay in the indoor unit, and how it's going to be used for airflow reduction. So this is a really neat thing. We're going to be reducing the airflow to 60%, approximately 60%. When the outdoor unit starts modulating back, it's going to generate a signal for us to operate a relay inside the air handler. Now, it should be noted, kit number HMH7 AK001 is recommended for convenience and supplied parts. So basically that kit, that 001 kit that we're talking about, is going to have a biflow filter dryer in there. It's going to have some pre-made harnessing and then a relay on a board. And so that kit number 001 will be used for the standard ECM motor. However, it should be noted that the HMH7AK002 relay kit, it may be used as well. However, because there's 2 relays on that board, you will not use the RV relay if you use the 002 kit. So the 002 kit, you can use it on the standard ECM motor. And please make a note of this. You have to use the 002 kit on a variable speed product. And we'll talk a little bit more about that later. And I kind of like to look at that 002 kit as almost like a universal kit in the fact that you can use it for anything, but you have to have it for the variable speed. And if you don't have the 002 kit, you can still use the 001 kit, which just has a single relay for the standard ECM motor products. An example would be like an AE air handler, or a TME furnace, or a TMY furnace. Those just use standard motors, standard high efficiency ECM motors, and so you'd use the 001 kit. Now, it should be noted also that this heat pump thermostat is going to have to, whatever heat pump thermostat you select, is going to have to be a thermostat that has a BO selection for reversing valve operation, because we're going to energize the reversing valve in the heating mode on this product. Unlike the rest of our Champion heat pump product, this one energizes the reversing valve in the heating mode compared to the O terminal in the cooling mode like we have on the other product. It's not bad, it's just different. And we just want to make sure everybody understands that. So any questions or comments so far before we jump into our block diagrams and a little bit deeper into our program?
We good?
Everybody good?
Yep, I think we're good, Joel.
Okay, sounds good. Okay, so let's take a look at the AE air handler with just a 2-stage, just a standard 2-stage heat strip. In other words, you're going to have a W1 and a W2 for auxiliary heat call. And so from the thermostat to the outdoor unit, we're going to have that B terminal going straight outside. Now, what that's for, again, we're going to energize the reversing valve in the heating mode. And so that thermostat has to have that BO selection, so you can select heating mode of operation on the reversing valve with that B terminal. W2 is your 2nd stage auxiliary heat if you've got like a 2-stage heat strip, and that's pretty straightforward. Just W2 to W2 would be the normal hookup on that. W1 from the thermostat is going to go to your 1st stage auxiliary heat, and if you just have a heat strip in there, W1 will be your 1st stage auxiliary heat. Now, on some thermostats, I understand Honeywell, they actually designate. For instance, one of our local companies a while back was telling me, actually, I think Christian McGinty out there at Chesapeake, Virginia, Nolan, had commented that the Honeywell thermostat, most of the Honeywell thermostats, the W1 call is actually an AUX or AUX auxiliary call. So please look at your thermostat, whichever thermostat you're using, and make sure that you know you have the right output for that thing. But W1 on our air handler is going to be our 1st stage auxiliary heat. Now, you'll also notice you're going to carry that outside, because remember, team, you're going to want to bring on some auxiliary heat during defrost. So the outdoor unit will generate a W call during defrost to bring that heat strip on during defrost, so you don't freeze the homeowner out when it goes into defrost. Because remember, anytime a heat pump goes into defrost, what does it do? It goes into the cooling mode of operation, doesn't it? So we want to bring on some heat so we don't freeze the homeowner out during that defrost mode of operation. Y terminal is going to go from the thermostat to the outdoor unit. This is your compressor call. You'll also notice on an AE air handler, you may have, now you don't necessarily have to have, but you may have a yellow wire if it's equipped from the factory. Go ahead and remove that yellow wire from the factory, that factory wiring, because we're going to be selecting speed taps on that ECM motor by way of our relay and some other functions. So go ahead and take that yellow factory wire off, because we're going to be using all the speed taps, or most of the speed taps, once we engage that relay. Common terminal will go from the thermostat to the indoor unit to the outdoor unit. That's, no pun intended, but that's a pretty common wiring scheme, if you will. Our terminal is our 24-volt hot. That will go from the thermostat to the indoor unit. Now, please note something. Our terminal does not go outside. So the outdoor unit does not require that 24 volts on the R terminal in order for it to function properly. So the R terminal will not go outside in this product. G terminals are 24-volt fan call from the thermostat to G. And what that's going to do, it's going to allow us to bring the fan on. Now, please note, if a homeowner goes over to the thermostat subbase assembly and selects just fan on, in other words, it's not calling for heating, it's not calling for cooling, they just want to circulate some air. Maybe they've got some indoor air quality products and they just want to keep the air moving. So we're going to recommend that G call from the thermostat to the indoor unit is on the lowest speed tap on that ECM motor. And that's just a very typical way to do it. So basically, you're going to have 1 through 5 speed tap. And I normally like to recommend just go G to speed tap number 1, and that'll give you a nice low airflow, running that filter, running the air across the filter, and keeping the air moving in the house. Really nice and quiet. So let's talk a little bit about this relay and how we're going to engage that relay for airflow reduction. So one side of the relay coil, now remember team, this is a 24-volt coil. This is a 24-volt coil and just a single pole double throw switching relay is all this is. You'll notice one side of that 24-volt coil on the relay goes up to S1 to the outdoor unit. The other side of the coil will go to C terminal, 24-volt C terminal for common. And as you notice outside, there's only 5 wires outside. You have a B, an S1, a W, a Y, and a C. And by the way, that's all you need outside is 5 wires to have full function with this unit. And we'll talk about that relay a little bit more in a little bit, but let's take a look at the common terminal on the switching contacts. That's going to tie into the yellow wire going outside for our compressor operation. So basically, anytime the compressor is running, we're going to have 24 volts on the common terminal for the switching contacts. Now, a very, very typical way to hook this up as well on the ECM motor is to go ahead and take on speed tap number 5, which is typically your high speed tap, take your high speed tap on the motor and just manufacture a wire or go up and hook up the high speed on the ECM motor to your W1 call. So basically, anytime you get an auxiliary heat call or anytime you go into defrost, we're going to go ahead and drive that fan to 100, not 100% airflow, but just a high speed airflow, whatever that happens to be. Now watch this. On the normally closed contacts, in other words, the relay is just sitting there. It is not energized yet. You haven't energized A and B, or the coil. You haven't energized or switched this relay. The normally closed contact on the relay is going to go to a speed tap. You're going to select a speed tap on the ECM motor to give you 100% cooling airflow. Now, team, remember, we're always going to recommend that you have 400 CFM per ton on your high speed or your 100% cooling airflow. So an example would be if it's a 2-ton unit setting outside, that normally closed contact, you need to select a speed tap that's going to give me 800 CFM. If it's a 3-ton unit, that normally closed contact on the relay, we're going to select a speed tap to give me 1200 CFM and so on. So we always want to drive that fan at 100% cooling airflow at 400 CFM per ton of cooling capacity of the outdoor unit. Any questions or comments on that so far?
No, I think we're good, Joel.
Okay. Now watch this on that switching relay. We're going to take the normally open contact on the relay, the normally open contact, and we're going to go over to the motor and we're going to select a speed tap that's going to give us about 60% airflow. Now, if you're kind of, when you select that speed tap, let's say you're on speed tap number 3 or 4, or maybe 2 or 3, and if you can you want to get real close to 60% airflow. If it goes up to 65%, that's okay. If it goes down to about 55%, that's okay. So really 60% airflow is kind of the target airflow. So in an example, let's say, for instance, we had a 3-ton unit. let's say this is a 3-ton unit, 1,200 CFM on 100% airflow. 60% of 1,200 would be 720 CFM or real close to it. So we want to make sure and select a speed tap on the normally open contact of that relay to give us about 60% airflow when the unit's calling for reduced airflow. So here's how all this works. The outdoor unit will modulate between 35 and 100% capacity. And what's going to happen is when it starts screwing down to around 60, 65% capacity, it's going to energize that S1 terminal outside and put 24 volts on that relay. Once it puts 24 volts on that relay, those contacts are going to switch. And we'll show you an animation of that in a little bit. Those contacts will switch and it'll drive the fan to about 60% airflow. So the whole purpose of that relay is to sit here and switch from high speed cooling airflow to low speed cooling airflow based on that S1 output from the outdoor unit when it's calling for reduced airflow because it's in a reduced capacity state. Any questions or comments so far on this idea of using that relay to switch and to command lower airflow when the outdoor unit has a lower point of capacity? Any questions on that? We'll show you an animation here in just a second, but any questions on that?
I think we're pretty clear on that one.
Okay, well, fantastic. So let's go ahead and do a little animation. Watch the PowerPoint closely. You'll notice that when we generate or when we energize that S1 terminal, we're going to switch that relay. Let me go back and do it one more time for you. So when the outdoor unit is saying, hey, give me reduced capacity, I'm at a lower point of modulation, bang, it's going to go ahead and energize S1. It'll switch that relay, and we're going to drive that indoor fan to that 60% airflow by way of that relay. In addition, I'd like you to note something. If W1 call is present, in other words, let's say I have an auxiliary heat call, or if a W1 call is present, what's going to happen, it's going to drive that fan to that high-speed airflow. Now remember, team, on an ECM type of motor or a variable speed motor, you can have multiple 24-volt inputs on those speed taps that won't hurt a thing. It won't burn anything up or anything. Unlike a conventional motor, if you were to energize a capacitor-style motor on multiple speed taps, it'd burn the thing up. Well, these ECM high-efficiency motors, that doesn't happen. You can have multiple 24-volt commands on that motor at one time, and what will happen, it'll just drive that motor to the highest command that it's receiving. So in this example here, if I get a W1 call, let's say I'm on a normally open contact and I'm, low airflow, for instance, and then all of a sudden I get a W1 auxiliary heat call. What's going to happen, it's going to drive that fan to that high speed tap that we hooked up for W1 for an auxiliary heat call. And even though it's calling for lower airflow, if it sees a higher speed command, it'll go ahead and take that command. We call that airflow priority on our ECM type of motors. Please note also a W1 call will be present with a thermostat auxiliary heat call or during the defrost cycle. So if this thing happened to be in a lower airflow, or if it happened to be in a lower airflow condition and it went into defrost, bang, it's going to go on up to a high speed airflow that you have set on that speed tap number 5 when you get a W1 call. Any questions or comments on how this is working? The relay is going to allow us to have reduced airflow, but also if we have a W1 call, it's going to drive that fan to that high speed tap. Any questions or comments on any of that?
No, I think we're good, Joel. Pretty straightforward so far.
Okay, that sounds real good. Well, listen, let's go ahead and jump on in and talk about some furnaces then. So the TME and the TMY furnace, the TME is a single stage furnace and the TMY is a 2-stage heat furnace, but they both feature that standard ECM, that high efficiency motor. So what we're going to do, we're going to look at the low voltage wiring of both a TME and a TMY furnace with a simplified block wiring diagram, just like we did before. Now, please remember, you're still going to use that wiring accessory single pole double throw relay in the indoor coil for airflow reduction. And again, that kit number 001 is going to be recommended for convenience and supplied parts. Now, the burning question I've had a couple of times from contractors that get a hold of me on the telephone said, Joel, if I can't get that 001 kit or that 002 kit, can I make up my own kit with just a peanut relay and just have a switching relay? And can I use my own bi-flow filter dryer and make up my own field wiring? Well, the answer is, of course you could. It's just convenient to have all this in one place in a kit. But the truth about it is, if you was kind of in a pinch and you didn't have a kit, you could still use just a little 24-volt coil, single pole, double throw switching relay, and put your own bi-flow filter dryer on the liquid line, because it's a heat pump, and then make up some field wiring and you'd be squared away. So it could be done in the field without this kit, but we're going to recommend these kits only for, mainly for convenience and all the supplied parts. Now, it should be noted the heat pump thermostat is still going to have that BO selection for reversing valve operation. And you're going to want to select a heat pump thermostat with dual fuel function whenever you use it with a furnace product. And let me stress that again, all the dual fuel function, if you have this on a furnace with the heat pump outside, is going to be at the thermostat level. So the thermostat's going to have to be able to either sense outdoor air temperature, to figure out its balance point and switch over point and all that kind of stuff. So be sure and select a heat pump thermostat with dual fuel function if you're going to be using it with a furnace product. Okay, so as we did before, we're going to go ahead and talk about this wire for wire. You're going to notice that on the furnace, it actually has hard screw terminals, and they're going to be labeled a little bit differently. For instance, on this TME furnace, we're going to have a Y1 and a Y/Y2 call for our cooling calls, but it is a single stage furnace, so you're only going to have one W terminal on the furnace. So let's go ahead and wire this thing up. So B terminal is going to go outside for reversing valve operation in the heating mode, just like we had before. W1 from the thermostat, or W from the thermostat if you just have a single stage heat thermostat or a single stage auxiliary heat thermostat. W1 will go out to W on the furnace, and that'll go outside for defrost mode whenever we call for defrost. We're going to bring the furnace on during defrost. Y terminal goes outside just like we did before. That's your compressor call. C terminal is going to be your 24-volt common, just like we had before. R terminal will be our 24-volt hot. Now remember, team, that does not go to the outdoor product. It just goes strictly between the thermostat and the indoor product. G terminal will be our fan call, just like we had before. G goes to G. Now please remember, we're looking at a furnace. We need a dual fuel thermostat if we're going to be hooking this up to a furnace, a heat pump with a dual fuel function. Other than that, it's pretty straightforward like we had before. One side of our relay coil is going to go to S1. The other side of the relay coil is going to go to common terminal. And then on the common terminal for the switching contacts, that's going to go up and hit yellow again, so that anytime we have a compressor call, we're going to energize that common terminal on the switching contacts. Now watch this, the normally closed contact on the relay is going to go to Y/Y2 for high-speed airflow, cooling airflow. And the normally open contact will go up and hit Y1 for low stage cooling, Okay. All right, so basically, if we have a TMY two-stage furnace, it's going to wire exactly like the TME furnace. So this is why we haven't changed anything on that part of it. The only difference between a TME and a TMY furnace is the fact that the TMY furnace is a two-stage furnace, and it's going to have a W2 and a W/W1 terminal. But other than that, everything wires exactly the same as far as the B terminal, the S1 terminal, everything wires exactly the same. It's just that on the TMY, we're dealing with a two-stage furnace now. So we're going to go ahead and take W2 from the thermostat over to W2 on the furnace, and then W1 from the thermostat to W/W1 on the furnace, and then W outside. So any questions or comments on how we're wiring up the single-stage TME and the two-stage TMY furnace before we do a little animation and show you how it's going to switch airflow like we did before? Any questions or comments?
No, we're still good, Joel.
Okay, sounds good. All right, so Let's go ahead and do that animation bang when we hit S1 on the outdoor unit. We're going to energize S1, and what it's going to do is going to switch that relay just like before and command low speed airflow. So just please remember the S1 relay or S1 from the outdoor unit is going to be your airflow reduction relay. And here we're going to be looking at shortly, we're going to be looking at some variable speed products. And please remember the variable speed product is going to have the 002 kit. Now, the easy way to remember that, the 002 kit is going to have 2 relays on there, which we're going to discuss here shortly. Okay, so this time let's go ahead and look at that low voltage wiring of an HMH7 heat pump with a variable speed air handler and a variable speed furnace. And just like we did before, guys, we're going to be looking at a simplified block wiring diagram and looking at it, wire for wire. Now, one thing I would let you note, or I'd ask you to please note, is that the terminals that are not being used for the HMH7 outdoor function are not going to be covered. Some examples would be, that Hume terminal has nothing to do with outside, so we're not going to be talking about that. That's more of a subject in our variable speed class. So you won't be using the Hume terminal for anything to do with outside. Same way with de-Hume terminals or the electronic air cleaner terminals on a variable speed product. Those terminals are going to be basically for indoor functions. And so we won't be discussing it in our block wiring diagram. Now, it should be noted the wiring of accessory relay kit 002 kit, that HMH7A K002 is going to be required because it has 2 relays on it. And because it has 2 relays mounted on the board, they're going to be designated RV and S1. So RV and S1 will be the designation on those relays. Now, again, we're going to recommend that kit for convenience and supplied parts. I had a question the other day from a contractor, though, our local company, I can't remember. They said, well, Joel, I don't have a 002 kit, but I've got a whole shelf full of relays. Can I use these peanut relays? Yes, but just remember, you're going to have 2 single pole double throw relays now, 1 bi-flow filter dryer, and you're going to have to make up some harnessing in the field. So they had a situation where they didn't have the 002 kit. They wanted to know if they could make up their own, or could they use 2 001 kits? And the answer is yes, you could. The only thing is if you use 2 001 kits, you'd end up with 2 filter dryers, which I guess you could put on your truck, and some extra harnessing. But kind of keep that in mind that the 002 kit is nothing more than 2 relays available on that board. One of them is going to be RV. The other one's going to be the S1 relay for airflow reduction. Now, guys, please remember this heat pump thermostat, it has a BO selection for reversing valve operation. That stays the same. And always remember, select a heat pump thermostat for dual fuel function when you use it with any furnace product. So let's take a look at this. So let's take a look at an AVC air handler. Now, down below, you'll notice I've got 2 relays down there, the RV relay and the S1 relay on the little graphic. So just like we had before, fellas, B1 is going to energize that reversing valve in the heating mode of operation. That does not change. And if you have like a 2-stage heat strip, W2 will be your 2nd stage auxiliary heat. W1 is going to be your 1st stage auxiliary heat, and that's going to carry on the outside, so we can bring some heat strip on during defrost on that W1 call. Y terminal is going to go outside just like before, as well as C 24-volt common. R is going to hook up just like it did before, and it does not go outside. And G is our fan call. So all of this wiring, is going to look real familiar to you. It's basically the same as everything else. And please note something too, that when you take a look at that outdoor unit, we're only going to still have 5 wires outside. Even on a high-end variable speed product, we're still only have 5 wires outside. And I think that's really cool myself. Okay, let's go ahead and talk about hooking up those relay coils at this time. So we're going to take one side of each relay coil, take it to 24-volt common. On the S1 relay, we're going to take the other side of the relay coil, and we're going to grab S1 just like we did before. This is our airflow reduction relay. On the S1 relay, we're going to take 24-volt common from the Y terminal and bring it down to the common terminal for the switching contacts, just like we did before. The normally closed contact on the S1 switching relay will go to Y/Y2. The normally open contact will go to Y1 for our first stage airflow. Now on the RV relay, we're going to take the other side of the relay coil. One side of the relay coil goes to 24-volt common. You'd expect that. The other side of the relay coil is going to go up and tie onto the B terminal for reversing valve operation outside. Now, this is how this works. When this thing goes into the heating mode of operation on the heat pump, it's going to energize that coil, that RV relay coil, and it's going to switch that relay. Now, the only purpose for this RV relay, by the way, is that during compressor operation, we're going to take 24 volts from the Y terminal and we're going to go to the common switching contact or the common terminal for the switching contacts on the RV relay. The normally closed contact on the RV relay is going to go up to O terminal. So here's the deal. On any variable speed product, fellas, in the cooling mode of operation, you know, if for advanced functions like cooling on delay, dehumidification, some of these other things, the variable speed product has to have an O signal on a heat pump so it knows it's in the cooling mode. So let me say that again. On any variable speed product, whether it's a furnace or an air handler, we have to have O energized on the air handler or furnace to tell that unit it's in the cooling mode of operation. So on this product here, we have to be able to provide that O signal in the cooling mode, and that's what we do with the RV relay. Now, when we go into the heating mode of operation and we energize B, what's going to happen, we're going to break that O terminal, and we're going to tell the air handler or the variable speed indoor furnace, if it's on a furnace, hey, we're not in the cooling mode anymore because we broke the O terminal. So please remember, on a variable speed product, we need that O signal, that O terminal energized in the cooling mode for advanced functions. Any questions or comments on how this is wired so far?
No, I think we're good, Joel.
Okay. So what we're going to do here shortly, we're going to show you the wiring scheme again. Remember that RV relay, the only thing that RV relay does is it switches the O terminal when it goes into the heating mode of operation. We'll show you an animation of that here in a little bit. On the TMY furnace, actually, excuse me, pardon me, the TMV. The TMV is a two-stage variable speed furnace. Fellas, it wires exactly like the AE air handler. I mean, the ABC air handler. It wires exactly like a variable speed air handler. The only difference is the terminal designation is slightly different. We have a W2 terminal and a W/W1 terminal on the furnace. Other than that, it wires exactly the same as far as the switching relays, the RV relay, the whole 9 yards. So please remember one more time that TMV furnace has to have a dual fuel capable heat pump thermostat on the wall for proper operation. So let's go ahead and do some animations real quick. So let's have some airflow reduction on this unit, whether it's a furnace or whether it's an air handler. So on any of the variable speed indoor units, let me back up and do that one more time. So when we want to reduce airflow, bang, just like we did before, we generate that S1 call outside. It switches the S1 relay and we command that reduced airflow when the outdoor unit is in reduced capacity. But now hang on a second, watch the animation on the left-hand side of the relay, on the left-hand side, the RV relay. When we go into the heating mode of operation and we energize B terminal, bang, what we're going to do, we're going to energize RV relay and we're going to break the O signal by that relay. Let me do that one more time. Watch the animation. When we go into the heating mode of operation and we energize B terminal for a reversing valve, we're going to bang, we're going to switch that RV relay and we're going to break that O signal. And what that does, it tells the indoor unit that we're in the heating mode of operation now on that variable speed indoor product. Any questions or comments on the relay logic of the RV relay and the S1 relay for airflow reduction and how all that works? Any questions or comments on how that works?
No, I think we're pretty clear. You went over it pretty well, so it cleared up my questions on it. So
Okay, good, excellent. Well, fellas, with that, let's go ahead and take a look a little bit. Let's talk a little bit about airflow considerations, because remember, on every install, you want to confirm proper airflow, especially on a modulating system. So the HMH7 is a modulating unit. It's going to modulate between 35 and 100% capacity, and nominal airflow is going to be critical. Now, this has to go with anything that's modulating, because the truth about it is any modulating unit is going to be looking at the refrigeration circuit and determining at what point of modulation or capacity reduction it's going to need. So ductwork sizing is very, very important. We're going to ask that you make sure and size your duct for 400 CFM per ton of total cooling capacity. Again, some examples I used earlier in our program today. If you have a 2-ton unit outside, you want to make sure that your ductwork is sized for 800 CFM. If you have a 3-ton unit sitting outside, you need to size it for a 1200 CFM. If it's a 4-ton unit, you're going to size it for 1600 CFM, and so on. So let's make sure that we have the proper airflow on these units. Now, one of the reasons I like to stress this a lot, fellas, is the fact that this HMH7 has got, I believe, 5 sensors on it. And it's looking at outdoor air temperature. It's looking at discharge line temperature on the compressor. It's looking at liquid line temperature. It's looking at suction line temperature. I believe there's a suction pressure transducer in there, so it's actually calculating superheat. The point I'm making is this: the outdoor unit has to have proper airflow on that indoor coil. Otherwise, it's going to think it's under a low load condition. To give me an example, let's say you have a dirty filter, a filthy evaporator, an undersized return air duct. You cats get the idea. And that evaporator inside starts icing up, or it gets too cold. Well, what's going to happen is going to drive the suction pressure down, the suction line temperature down, the liquid pressure is going to go down, and so on. And so the outdoor unit is going to perceive that as a capacity reduction, or there's less heat load in the structure, and it's cooling down, so it's going to start modulating back like it's supposed to do. So please remember, airflow is important on everything, but on a modulating system that's got these multiple sensors on there, airflow really becomes critical, that we provide that proper airflow, and we keep our coils clean, and we have a clean air filter, and all those important things that we should be doing anyway. But it really becomes important on a modulating unit, because it'll actually start reducing capacity if you got a filthy filter. So just think about that a little bit as you start thinking about airflow considerations. In addition, as a quick reminder, the velocity tables that are in Manual D, ACA Manual D, be sure when you're building your duct systems or modifying your duct systems to try to go with your recommended velocities on your key components, like your main trunk. For instance, the recommended velocity is going to be 700 feet a minute on the supply, 600 feet a minute recommended on the return on those main trunks. Your branch runs are going to be 600 feet a minute on the supply, and 400 on the return recommended, and so on. So look at this table in Manual D. This is right out of Manual D. I'm not going to go over every single one, but you can kind of read it yourself. Registers and grills and diffusers are all going to have recommended velocities and maximum velocities, and we always like to go with the recommended velocities. Now, one thing that's really, really important, depending on what area of the country you're in, you may have a filter grill or a return air grill with a filter in it. Well, if you do, please remember, Manual D recommends a maximum velocity going across that filter grill with a filter in it, not to exceed 300 feet a minute face velocity. So all of these things become, again, really important, when you're putting in a system in general, but also these modulating systems. We want to make sure we give them the right airflow, and we want to make sure that the velocity across those key components like main trunks and branch runs and all that, and registers, are within Manual D recommended velocities as we build that duct system out. So with that, any questions or comments on what we talked about today? That pretty much concludes the program, but I'd like to go ahead and open the floor up. And in fact, let me go ahead and stop the PowerPoint and go back and open up the, we'll go back and put my camera back on. I'm going to stop sharing my screen. And we're going to go ahead and open up the floor for a few minutes for any questions or comments on the program this evening. Now, remember, guys, we're going to house this out on the YouTube training channel. And we'll get that out there later on tomorrow. And so you'll be able to look at this video as much as you like. But any final questions or comments before we secure for the evening?
I think we're mostly good on our end, Joel. I think you covered quite a bit in depth there, and
Okay.
it answered most of my questions I had. So I really appreciate you doing this.
Absolutely. All right. Well, good deal.
Hey, Joel. Joel,
Yes, sir.
can you hear me?
I can.
This is Mike Vitens. I have a question for you, I guess not in regard to anything that you covered, but
Okay.
with the HMH7, have a scenario I want to put by you and just see what your opinion is.
Sure.
Let's say we get down the road a bit. This is inevitable that it will happen. We've got a dealer out there. Technician goes back to one that's installed. We've got a low pressure issue, and for whatever reason, there's some type of a leak. Let's say there's a little kind of a real slow pinhole seep at a braze joint. Okay.
Okay.
They've found it. Either the weather's poor or they've got 3 days worth of calls to do, but they want to get a customer taken care of. Not losing it at a great rate, maybe a couple ounces a week. So
Okay.
they just they want to put some additional charge in to get them over the hump for a week or a month, whatever.
Okay.
How would we go about doing that without weighing the charge out, repairing the leak, repressurizing it, weighing the proper charge in? Is there any type of values we could get a hold of as far as we would force the HMH7 in either air conditioning or heat pump mode, force it to 100% to a certain duration of time where we know that's not going to be modulating, up and down on us, and we would have some type of target converted pressure numbers where we would have some superheat and subcooling values that we could somewhat charge to?
I love that. Great question. The truth about it is, even though our factory recommended charts are always going to be driven towards weighing it in, that's what they want you to do. Now that we had that talk, the truth about it is it's a heat pump. Now it does have an electronic expansion valve outside. However, when you drive the thing to 100% capacity in the cooling mode, it's going to drive that EEV wide open. And so now the expansion valve on the indoor coil is just a conventional plain Jane mechanical expansion valve, right? So based on the length of your line set, let's say it's just a pretty common, 25 to say 35 foot line set. What you're going to do in that situation, now we always recommend you weigh it in. Now that's what the factory charts call for. But the point is if it's stable, it's running, it's on high speed, it's in the cooling mode, give me about 10 to 12 to 13 degrees of subcooling. That's going to get you real close, at least until you can get that thing fixed and stuff like that. So guys, even though it looks, complicated and it's modulating, the truth about it is at 100%, the dumb thing is it's just a heat pump. So to your good question, 10 to 12, 12 to 14 degrees of subcooling on an average length line set up to maybe 35 or 40, 50 feet in the cooling mode at 100%. That's going to get you pretty close.
Okay. Thank you, Joel.
Yes. Good question. Any other good questions or comments? Well, fellas, I'm going to go ahead and stop the recording. And at this time, I'm going to go ahead and stop the recording. We'll have that housed out on the YouTube channel sometime tomorrow.